Now, I want us to factor f of x. Our goal is to factor f of x. And we want to factor, right? A mathematician tells you that f of minus 2 plus I is equal to 0. Suppose that's given. I don't advise we try to check it, right? That would be a real pain to check, wouldn't it? Suppose you know. You're given this, right? What did the complex factor theorem tell us? Do you guys remember? Each complex root corresponds to having a quadratic factor. What quadratic factor is that? If I have this as 0, that means that there's x plus 2 quantity squared plus 1 is a factor, right? Which is x squared plus 4x plus 5. So this, allegedly, is a factor of f of x. All right? And we figured out how to do that factoring through some kind of like annoying algebra on the factoring. We introduced a variable and did some kind of like fussy stuff to do this. Now we can just divide. So if we divide x squared plus 4x plus 5 into this, this should show us what the cofactor, if you will, the whatever thing we multiply by this to get f of x. So what would my division start with here? I guess this was example 7, right? So to get x to the 4th, I have to multiply this by x squared, right? Now x squared times this gives me x to the 4th plus 4x cubed plus 5x squared. All right? And now I subtract. So going back to your question about bringing stuff down, I need to be sure I bring enough, I need to make sure I bring down things that are interacting with the multiple I'm currently subtracting, like otherwise you'll eventually get into trouble. So the x to the 4ths cancel, and you get what? Negative 2x cubed, I like it.
And minus 9x squared.
Minus, oh, but that minus a minus though, right?
Oh, yes. Oh, 23.
I think, no, minus, oh, hold on a second here. Oh, that should have been minus what? I was fished in. 2 minus 4 is what? Minus, rather, excuse me.
Minus 6.
Minus 2 minus 4 is minus 6. Yes, thank you. Minus 14 minus 5 is?
23.
Minus 14 minus 5. Minus 19, right?
Wait, but you have the positive and negative.
But this...
Oh, my brain. I read that as a 9.
Oh, sorry. That's a 5. Yeah. Oh, I gotcha. Yep. Fair enough. Yeah, well, I have been criticized for my 5s there. It's more 5-y. And then I'll bring down the minus 10 and the 25, all right? So, all right, so then what's up next? To get this one, yeah, minus 6x. See, because minus 6x times x squared gives me minus 6x cubed. And then minus 24x squared minus 30x. I put some parentheses to remind myself I'm subtracting all those things. All right? So of course the minus 6 cancel, right?
And then it would be 5.
Mm-hmm.
Minus 5.
No, this time plus 5, because minus a minus gives me 24 minus 19. So 5x squared plus 20x plus 25. And then we do plus 5. And that gives me 5x squared plus 20x plus 25, which delightfully gives me a remainder of 0, right? So what's all this mean? This means that x to the 4th minus 2x cubed minus 14x squared minus 10x plus 25 is equal to, in fact, the product of x squared plus 4x plus 5 with x squared minus 6x plus 5. Now, if the instructions were to completely factor f of x, we're not done yet, are we? Because if we're completely factoring over the reals, well, the first piece is done because it's what? It's prime. But how about x squared minus 6x plus 5? Can we factor that?
Yes.
Yes.
Yeah.
So x what?
Minus x minus 4.
X
X minus 5, x minus 1.
There we have a consensus, x minus 5, x minus 1. As you know, math is done by consensus. Therefore, this is correct. Oh, I'm sorry, that's actually not true. There you go. Factored. So you see, if we have information about a polynomial, if we know that there's a factor there, we can use long division to actually figure out what the factor is next to the given factor, right? We can find out the cofactor using long division, like this.
Will we be given what to divide it by, or will we have
Oh, yeah. I mean, there has to be some kind of hint given, right? So like the way I can give hints is I could just say, this is a factor, right? That would be the easiest way. I could be kind of coy and tell you, well, this is 0, which is an invitation for you to use the complex factor theorem. Or I could do something else like, f of 3 is 0, and then that would say x minus 3 is a factor. That would be an unfriendly hint, since x minus 3 is not a factor of this, right?
Yeah.
So anyway, there's much more to talk about that, but I just wanted to get us started on I wanted to talk a little bit about, this is something we're going to do a lot of. So, yeah.
So for the f of x minus 2 plus I equals 0,
Mm-hmm.
we can do, like, we got the x plus 2 squared plus 1 by,
This is the complex factor theorem, which we talked about before, but it's been a little bit. The derivation of it was this. You've got x minus 2 minus I, or x plus 2 minus I, times x plus 2 plus I, because they come in conjugate pairs, and if you multiply that out, it works out to x squared plus 1, x plus 2 squared plus 1. But again, we worked it out before. Anyway, hey guys, have a good break.
I'm going to miss you, Mr. Cronin.
Oh, you're not coming back? You can watch my videos.
Oh, I will.
We'll still have the videos.
Don't worry, I know you'll miss me too.